Hello students, how are you all? I am Sagar and you are watching Shruhi Study Point. Today we'll solve some question of NEET of the year 2017. Let's see what has said in this problem. A capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy of the resulting system, there are four options. Which will be correct? You have to find out. Let's see. Suppose this is a capacitor which is fully charged by any battery. When this capacitor is fully charged, suppose at that time the charge accumulated on the capacitor is Q and the potential difference between the plates of the capacitor is V. This is fully charged capacitor. In this situation, energy stored in the capacitor is half CV square, where C is the capacitance of the capacitor. Now this fully charged capacitor is connected to another capacitor in parallel. This is the diagram. Suppose this is first capacitor and this is second capacitor, and they are connected in parallel. In this case, the charged capacitor, that is number 1 capacitor, will gradually decay the charge, and the second capacitor will gain the charge gradually. So the potential of the first capacitor will be decreased and the potential of the second capacitor will be increased, and a time will come when the potential difference of the two capacitor will be same. Suppose V by 2 is the potential difference of the first capacitor and V by 2 is the potential difference of the second capacitor. The capacitance of the first capacitor is C, the capacitance of the second capacitor is C. So in this situation, the total energy of the capacitor will be, the energy of the first capacitor is half C V by 2 square plus the energy of the second capacitor will be same. So the total energy will be 1 by 4 CV square. You can see U is the initial energy, U1 is the initial energy and U2 is the final energy, and U2 is less than U1. So option number A will be correct. The total electrostatic energy of resulting system decreases by factor 2. Okay, let's see the second problem. Look at the second problem and read carefully. Suppose the charge of a proton and electron differs slightly. One of them is minus E, the other is E plus delta E. If the net electrostatic force and the gravitational force between two hydrogen atoms placed at a distance d apart is 0, then delta E is of the order of, there are four options. Which will be correct? Let's check the problem. Suppose this is electron and the charge of the electron is minus E, and this is proton. Okay, and the charge of proton is E plus delta E. In general, we know that the charge of electron and the charge of proton are same, but in this case the charge of electron and the charge of proton are not same. The charge of proton is greater than the charge of electron. Okay, there are two hydrogen atom. This is an hydrogen atom and this is another hydrogen atom. You know that in hydrogen atom, in the nucleus there is only proton. Okay, and the outer orbit, in the outer orbit there is only an electron. Suppose this is electron of hydrogen atom. The protonic charge, that is the charge of the nucleus, is E plus delta E and the electronic charge is minus. The net charge of the hydrogen atom is delta E. Okay, the net charge will be the charge of nucleus plus the charge of electron. So the net charge will be only delta E. So this is an hydrogen atom. The charge of hydrogen atom is delta E and the charge of another hydrogen atom is delta E. Now these two hydrogen atoms will repel each other because they carry same charge. So they will repel each other and the electrostatic force will be 1 by 4 pi epsilon naught delta E into delta E, that is delta E square, divided by the square of distance between them. Okay, now due to mass, these two hydrogen atoms will attract each other by gravitational force. Okay, and this gravitational force is G m into m, that is m square by d square. In the question it is given that the electrostatic force and the gravitational force will cancel each other, so we equate them. Okay, and from this equation you have to find delta E. Delta E will be root over G m square into 4 pi epsilon naught. Okay, the value of G is given 6.67 into 10 to the power minus 11. The value of protonic mass is 1.67 into 10 to the power minus 27 square, and you know the value of 1 by 4 pi epsilon naught, and the value of this quantity is 9 into 10 to the power 9. So you have to put 1 by 9 into 10 to the power 9. Just you have to calculate this term and you will get the correct option, and here the correct option will be near about 10 to the power minus 737 coulomb. Okay, so the correct option is B. Read this question very carefully. There are 4 diagrams given and all are equipotential surfaces. Now look at this problem. Now look at the first diagram. These lines denotes equipotential surface. Okay, in the case of first surface, the potential is 10 volt In the case of last surface, the potential is 40 volt. So if you want to move a charge Q from point A to B, you have to do work, and this work is WAB is equal to charge into potential difference between the points, that is VB minus VA. Okay, charge is Q here, and the value of potential of the point P is 40 volt, and that of the point A is 10 volt. So the work done will be 30 Q. Okay, the work done for second diagram will be Q into VB minus VA, that is for the point B the potential is 40 volt, and for the point A potential is 10 volt. So here you will get 30 Q. If you calculate work done similarly, in each case you will get work done 30 Q. So for all cases, for all the diagrams, the work done is same. Let's check which option is correct for this question. Option A, in all the four cases work done is same. This is the correct answer. We have solved three important problems of NEET. These problems came in the year 2017. We will solve more problems in the next video.